All right, so today we're going to do what appears to be a really easy section, right? And it actually isn't too bad. We're going to talk about areas of triangles, okay? Now, with right triangles, we're all pretty familiar with the formula for the area of a right triangle, correct? So our first one on our little starter question there, what is that? What's the area of this triangle here? Yeah, it's 1/2 BAB, right? 1/2 the base times the height. Okay. Now, what about the next one? Now we have a little bit of a problem, right? So what we're going to do today is we're going to develop, or we're going to give you formulas so you can find the area of any triangle. Okay. Doesn't have to be a right triangle. Okay. Now, obviously the A equals 1/2, base times height or whatever, that does work for any triangle, but you have to know what the height is, okay? What we want to do here, okay, is develop formulas so we don't have to know the height, okay? And we do it using our trig functions, okay? So if we look here now, finding the area of a triangle is easy if you have the base and an altitude, okay? And remember, the altitude is simply the height, okay? So like for this one here, right, the area, and I'll make that a capital A, is equal to 1/2 base times height. Okay. All right. Now, if we use this technique, okay, that can lead to some easy formulas. So how do I get this first one here? When I get A is 1/2 BC sine alpha. What the heck? How do I get that? So essentially what have I done? I've taken H and replaced it with C sine alpha, correct? Now is H equal to C sine alpha? Can we verify that? Yeah, we can, because if we do the sine of alpha, right, the sine is what over what? Opposite over hypotenuse. And in this triangle right here, what's opposite of alpha? H. And what's the hypotenuse? C. So H does equal C sine alpha. So that's where that formula comes from. Okay? Pretty basic, pretty simple. Now we can apply that to all of our angles now. So if it's 1/2 BC sine alpha, then it's going to be 1/2 AC sine beta, good, and then it's 1/2 AB sine gamma. Okay? So you can remember all the formulas, or you can remember the area of the triangle is half the product of the two sides times the sine of the included angle. Oh my goodness. That's a C. Okay, that's really bad. All right, so let's look at example 1 here. Okay, and let's go find and let's find this. So we have A, B, and gamma. So how do we find the area? It's going to be 1/2 A, which is 12, times B, which is 6, times the sine of gamma, which is 15. Now we don't have Alec as my calculator guy here, although it looks like Ethan's on it today. So we get 1/2 of 12 is 6, 6 times 6 is 36, so your 36 sine 15 is? 9.3. And it's in whatever units it is, this isn't specific, so 9.3 inches squared, or if there isn't, you can just put units squared. How about that? Okay. All right, now, so that formula works well if we have two sides in the included angle, okay? But what if we have all three sides and don't want to bother with law of what to find the included angle? Yeah, law of cosines, right? Because that law of cosines can get a little tricky. Okay? Now, that's what the next formula comes in handy, okay? And it's called Heron's formula. Al, we all right there, buddy? All right, good deal. Okay. All right, so Heron's formula is simply the area equals the square root of S times S minus A times S minus B times S minus C. Now, what is S? Okay. S is basically the, what's called the half perimeter. And it's given by S equals A plus B plus C all over 2. Okay. All right, so let's find the area of a triangle if we know side, side, side. Okay, so we need to find the area of the triangle with A is 16, B is 9, and C is 10. Now, do we have a triangle? You remember how do we determine if we have 3 sides? How do we determine if we have a triangle or not? Yeah, the 2 smaller sides have to be greater than the longest side, correct? So do we have a triangle here? Yes. Why, yes, yes we do. So let's figure out S. So S is equal to, thank you, 17.5. Man, I'm glad you guys are on top of this. Okay, so now our area then is equal to the square root of 17.5 times 17.5 minus 16, which is 1.5, times 17.5 minus 9, which is 8.5, times 17.5 minus 10, which is 7.5. So multiply those together and take the square root, and we get okay. All right. Not too bad. Sweet. All right, so let's do these last little parts of example 3, and then we are done today. Like you say, give you a nice easy one, head into spring break, right? Please, Amber, control your enthusiasm. All right, so let's do part A here. So first of all, do we have a triangle? Yes. Yeah, okay.
Yes.
On part A, right? Okay, good. So let's find S. So S equals, let's see, 12 plus A is 20, yeah, so S is 13. Good, so now the area is equal to the square root of 13 times 1 times 5 times 6.
I know.
What we got, E?
Wouldn't it be 1 times 5 times 7?
Oh, yeah, 13 minus 6 is 7. Good call. Everybody agree? Joshua? 21.3, Josh? Right. 21.3? Yeah, and that's, yes, that is units squared, whatever that would be, because we are talking an area here. Okay? All right, so now we have alpha and beta and gamma. I'm sorry, we have A and beta and gamma, not alpha. So, what do we do here?
You have to find, well, we can find alpha, but then you...
Yeah, okay, we can find alpha, so what's up? So let's do that. So what's alpha?
50.
Okay, so alpha is 50, right? But to do an area, we need to have what? We need to either have all sides or side angle side, right? So I've got all the angles I need, right? But I need another side.
Law of signs.
What was that?
Law of signs.
Law of signs. We can use law of signs to find that. Okay. So let's see, and we need B or C, and it doesn't matter which one. Let's go for B. So we're going to go B over the sine of 33 equals A, which is 25, over the sine of alpha, which is 50. Okay? So then B equals 25 sine 33 all over sine of 50. B is 17.8. Thank you. Okay. Now we're ready to use our area formula. Okay. So now let's make sure we use all the right parts though. No. Because we only need side angle side to find the area. Right? We're not solving the triangle. Now if we were solving the triangle, yes, we would absolutely have to find C. Okay? But all we want to find is the area, so we either got to have side, 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 or side angle side. Now that we've got side angle side, okay, we got two sides and all the angles. Now we can use the first area formula. Yes.
So is that 17.8 or is it?
It's 17.8. That's my little dot. See that little dot right there? Seriously.
Okay. Well, 'cause
You want to teach this?
that wasn't there before.
Actually, maybe I'll have you write it and then I'll just explain it. Yeah, so we got to think about that. And then y'all can laugh at Amber Lee for her crappy writing, because it's no picnic writing with this thing, right? Okay. All right, so our area then is 1/2. So now which formula are we going to use here?
The third one.
Okay, so that's 1/2 A times B, and A is 25. B is 17.8 times the sine of gamma, which is 97. Plug and chug. Say that again, Josh. 220.8. Man, I hope you guys are doing right on these calculations, because I'm trusting you and I'm publishing this stuff.
Look at the third.
Look at the third one.
Oh, okay.
Because that's the side angle side thing, right? So I have side A, side B, and then I have to use angle gamma. So that's the one that's in between those two. Does that make sense?
Yep.
Okay.
A and B isn't greater
I'm
than,
so happy about that.
What's that?
plus B isn't greater than, or the one beside A plus.
We don't have C though, so.
Yeah, we don't know
Oh,
C
we don't
yet.
have C.
Now, again, we could find it, but if you have side angle side, then you're pretty well okay. Because basically, by calculating C, we can make C anything we want, you know, I mean, as far as, I mean, it'll be, if we use law of sines and calculate C, law of sines is assuming we have a triangle, we'll be okay. All right, is that it? Holy cow. Merry Christmas.